my YouTube channel. Once again, my name is Isaac, and I would like to update us on my learnings at Blockfuse Lab Week 2. Okay, so earlier last week, I made a post on my LinkedIn account, which I'll be sharing with us today so we can all get updated on my learnings at Blockfuse Lab. Okay, so earlier last week, I learned about gas, the gas mechanism in the blockchain. Why do we use gas? What are gas used for? Okay, so this week at Blockchain Lab, I learned about the concept of gas in the Ethereum blockchain and its relation to Turing completeness. Remember in my last video, we talked about Ethereum being a Turing complete Ethereum, we talked about Ethereum being Turing complete, okay? And what that means is that according to Alan Turing, often regarded as the father of computer science, a system is said to be Turing complete if it can run any computation given enough time and resources. Okay, let's say, for example, a real world scenario like a printer, for example. A printer is Turing complete in the sense that you can give it a set of instruction, it reads those instructions and sets them to memory. So that's a Turing complete machine. So it's simply a system that can do computations and store them to memory. Okay, so Ethereum is a Turing complete system because it can execute stored programs, which we call smart contracts in this case. So the ability of Ethereum, unlike blockchain, to execute smart contract is what makes Ethereum to be Turing complete. And the machine which helps Ethereum to run smart contracts is regarded as the EVM, which is the Ethereum virtual machine. Okay, so now, however, Turing completeness are faced with the halting problem. Now, what do we call halting problem? Remember, I used a printer, for example, that a printer is said to be Turing complete. Imagine a case scenario whereby you send a file to your printer to print, then the printer hangs and is unable to print the file. What do? You switch off the printer and what and switch it back on again, and it begins to work again. Okay, but what if such a problem happens on the blockchain? Are we going to switch off the blockchain and switch it on again? Is there something like that? No. So that is the problem with Turing complete system. It is called the halting problem. Okay, and the reason this happen is the fact that Turing complete system cannot predict how long a program will take to run. Okay, so I said, however, Turing complete systems are faced with the halting problem. The halting problem refers to the fact that a Turing complete system cannot predict how long a program will take to run. That is, it does not know how long a program will take to run without actually running that program, or even if it will never finish at all without actually running the program. Okay, so this creates the risk of programs entering infinite loops, which could potentially crash the system. Okay, so remember, if in case you are new to programming or you already have prior knowledge of programming, there's something called infinite loops. So when you run an infinite loop on your laptop or your private computer, it can crash your laptop, it can crash your program. The CPU heats up, the resources get wasted, like it uses up memory a lot, and your laptop can hang. So that is basically what running an infinite loop can cause. So now this type of thing can actually come to play also on the blockchain because it's also a Turing complete system. So how do we prevent that? So how does Ethereum prevent this? As you might have guessed, the answer lies in its gas mechanism, in the sense that Ethereum introduces a metering mechanism called gas to address this issue. As the Ethereum virtual machine executes a smart contract, it accounts for every instruction, whether it's a computation or data access. What this means is that as the Ethereum virtual machine, the EVM, executes a smart contract is just a bunch of code or a set of instructions given to the EVM to run. Okay, so now as the EVM is running that smart contract, it accounts for each computation is doing. It's just like me giving a person a task to do, and the person charges me for doing that task. So that is basically how it works. So the function of this is such that if the smart contract rather contains a condition that might result in an infinite loop, which will cause the halting problem, then the gas for that will be what? Will be more. So when even the EVM wants to run a smart contract, there's a certain amount of gas that is allocated to run that smart contract. So once the gas finishes, the execution stops. So let's read. As you might have guessed, the answer lies in its gas mechanism. Ethereum introduces a metering mechanism called gas to address this issue. As the EVM executes a smart contract, it accounts for every instruction, whether it's a computation or data access. Each instruction has a predetermined cost in unit of gas. When a transaction triggers the execution of a smart contract, it must include a specified amount of gas. Okay, so setting an upper limit on the resources that can be consumed by the contract. If the gas is exhausted before the contract finishes execution, the EVM will terminate the process, effectively preventing infinite loops and ensuring the system stability. So you might be wondering, why do we pay gas on the blockchain on Ethereum? Well, sometimes, in fact, most times people complain that Ethereum's gas fee is way high than other blockchains. Okay, so the reason why we pay gas is to address the halting problem. Okay, so the gas mechanism not only safeguards Ethereum from the halting problem, but also plays a crucial role in its overall security and efficiency. Is that clear to us? I believe we have a better understanding of how gas works on the Ethereum blockchain. So the reason why the gas mechanism was being introduced is to address the what? The ultimate problem. Okay, thank you very much. I look forward to posting my next video. Oh yeah, that's true. I have something else to share with us. I'll post that in the next video. Thank you very much.